In this lesson, I'll show you 3 examples on how to use the chain rule to find the derivative of a function. Let's begin with question 1. The question asks us to take the derivative of y is equal to x to the power of 3 plus 1 to the power of 5. The first thing that you do is, just like in the power rule, you'll take your exponent and subtract it by 1. So we have y prime. Y prime represents the derivative of y. I'll write down x to the power of 3 plus 1, and like I said, 5 minus 1. At the same time, you will take this 5 and multiply the whole expression by 5. And not only that, you will now need to find the derivative of the base. And this right here represents the base of our function. So to find the derivative of x to the power of 3 plus 1, we apply the power rule. And I'll do my work over here, and I'll call this part g. Okay? So this is g of x. G of x is equal to x to the power of 3 plus 1. I'll use the power rule for both of these terms. This becomes 3x to the power of 2. And finding the derivative of any constant is 0. You'll take this derivative, which I'll call g prime, and multiply this whole expression by 3x to the power of 2. So multiply 3x to the power of 2 to what was remaining. This leaves us with y prime. 3 times 5 is 15. X to the power of 2 stays the way it is. This part becomes x to the power of 3 plus 1 to the power of 4. So this function right here is the derivative of what we started with. Let's summarize what we just did. We used the power rule by subtracting this by 1 and then multiplying the whole expression by the exponent, and in our case it was 5, and then I multiplied the whole expression by the derivative of the base of the exponent. Let's move on to question 2. In question 2, they ask us to differentiate the equation y is equal to the cube root of 1 plus x to the power of 2. Instead of writing it in radical format, you can write it down as a fractional exponent. So this becomes y is equal to 1 plus x squared to the power of a third. Mathematically, this expression and this expression mean the same thing. Now we can apply the chain rule. We can subtract 1/3 by 1, multiply the whole expression by a third, and find the derivative of the base. Let's find the derivative of, and I'll call this g of x. So let's find the derivative of g of x. We end up with the derivative of 1 is 0, and the derivative of x to the power of 2 is 2x. This gives me y prime, and remember this 2x will be multiplied to this expression. 1 plus x to the power of 2, and a third minus 1, you can use your calculator for that. A third minus 1 gives us negative 2 over 3. Negative 2 over 3 times a third times 2x. You have officially found the derivative. The only thing you can do from here is to simplify this expression even more, and that's not hard to do. 2x times a third is 2x over 3. And here we have an expression where the exponent is negative. Normally your teachers don't want you to write down negative exponents. So to make this into an expression without negative exponents, you can rewrite the base at the bottom, 1 plus x to the power of 2 to the power of 2 over 3. Notice now this expression no longer has a negative exponent. And of course you can further simplify this. In case you're curious, you can write it out as 2x over 3 third root of 1 plus x squared to the power of 2. Let's continue. In question 3, they want us to find the derivative of 5 over the square root of x to the power of 2 plus 3. Then they want you to evaluate it at 1. Let's start by rewriting the function in a way that's more understandable. 5 times x to the power of 2 plus 3 to the power of negative 1 over 2. In case you're curious, what I did was first change the denominator into a fractional exponent. Remember, the square root is always the same thing as to the power of half. And then instead of writing it at the bottom, I flipped it and changed the exponent to negative half, and you can do that. I'll use the chain rule now, subtract this by 1, multiply the whole thing by negative half, and then find the derivative of this part. The derivative of this part is simply 2x, giving us f prime at x is 5 times negative half times 2x times this part, which remains unchanged, to the power of negative 1 over 2 minus 1. I'll use my calculator for that. Negative 1 over 2 minus 1 gives me negative 3 over 2. Negative 3 over 2. I've officially found my derivative. All I have to do now is substitute 1 into this equation. Let me use my calculator. 5 times negative 1 over 2 times 2 times 1. Remember, I'm replacing all the x's with 1's. That gives me negative 5 times, now this part, 1, because 1 to the power of 2 is 1, plus 3 to the power of negative 3 over 2. This gives me negative 5 over 8. So the derivative at 1 gives us a rate of negative 5 over 8. And there you have it. 3 examples on how to use the chain rule to find the derivative.